Kia ora, Year 9. Here are the last few questions from the JAF practice. These are relational questions, and the first 4 of them are ones where we have to write the equation. So I'm going to blow them up a bit bigger so you can read them. Have a go at them before you watch this video. The last question, question 38, is one where we have to draw the graph, and I'm going to do that using 2 different methods. Okay, so first we have to form the equation for each of these word problems, and then we have to solve the equations. So you can use any letter for your variable. I'm usually going to use either n or x. So number 34, I start with a certain number, I add 3 to it, and then I divide the result by 5, and this gives me 2. So notice that we have to form the equation and then we have to solve the equation. So we can't just write down what the number is. So starting with a certain number, let's call it n, and we add 3 to it. Then we divide the result by 5. So that means we're taking the whole of that n plus 3 and dividing by 5. That gives me 2. So what did I start with? So we're told that we need to solve the equation to do that. I'm going to times both sides by 5. I get n plus 3 equals 10. Now I'm going to subtract 3 from each side and I get n equals 7. So there you go. Now you don't have to do your loops to show you working. It's fine to just set it out logically like that. Okay, next one. The mean of a certain number and 5 is 10. Right, so the mean is the average. So let's call my number x this time, just to change it around a bit. So I've got my number, and the mean of that number and 5 is 10. So to find the average, we take the 2 numbers, we add them together, and we divide by how many numbers there were. So it's x plus 5 divided by 2, because there are 2 numbers. So x plus 5 divided by 2 equals 10. Solving that goes like this. First we multiply by 2, so we have x plus 5 is equal to 20, right? So I'm undoing the last operation each time. I'm using the inverse of dividing by 2, which is multiplying by 2. Right, x plus 5 is 20. Now we subtract 5 from each side and we get x equals 15. So the number is 15. On to question 36. Adding 15 to a certain number and dividing the result by 4 gives the same result as subtracting 2 from that number. So let's let that number be n. So we take n and we add 15 to it. Then we divide by 4. Divide the result by 4. So that means I'm dividing all of that by 4. Okay, so n plus 15 divided by 4 gives the same result as subtracting 2 from that number. So that's n minus 2. To solve that, we're going to multiply both sides by 4. So we get n plus 15 is 4 times n minus 2. N plus 15 equals 4n minus 8. I'm expanding my brackets. Now I'm going to subtract, what am I going to do here? I'm going to subtract n from both sides, leaving me with 15 is equal to 3n, take away 8. Remember, I want to get the n's on one side and the numbers on the other side. And now I'm going to add 8 to both sides. That gives me 23 is equal to 3n. Dividing by 3 on both sides gives me n is equal to 23 over 3. Now you can go back and you can check that when you substitute that into there, you get the same as what you get when you substitute it to the right hand side. So the number is 23 over 3. The next one is one where we have to write an equation, but we don't have to solve it. Okay, so a jet uses 50 litres of fuel to take off, and it uses 100 litres for every 125 litres for every 100 kilometres it travels. So it's 125 litres per 100 kilometres. We're told that if k is equal to the number of kilometres the jet goes, write an equation for the amount of litres of fuel the jet uses. Now notice here that k is not a unit of 100 kilometres. K is just the number of kilometres. So what we have to do first here is to say, well, what's the extra fuel usage per 1 kilometre? It's not 125, it's 1.25 litres. So you could think about doing a table for this if you find it hard, where you say, when we do 0 kilometres, the jet uses 50 litres. Where we do 1 kilometre, the jet uses 51.25. Okay, so that means that my equation is going to have an intercept of 50, so it'll be L is equal to 1.25 K plus 50. So there we go, that's that equation. Now the last question in this video is a little bit different. We have to draw this line, 3y minus 4x is equal to 12. And you'll notice that that's not in our usual format. We've got two options for how to do this. We can either rewrite it to get it into y equals mx plus c form, or we can use the cover-up method. So I'm going to do that first. We've got 3y minus 4x equals 12. So let's look at what happens when x is equal to 0. So we've done this in class where I cover things up on the board. But we're really substituting a value and then saying what must y be. So when x is equal to 0, this term here is 0. So we're left with this, 3y equals 12. Magically we'll get rid of that. Okay. So more elegantly, we've got 3y equals 12 and y equals 4. So that means that the point 0, 4 is on my graph, and that's going to be the y-intercept. Right? Now we can do the same thing when y equals 0. So when y equals 0, I'm going to cover up this, and I'm left with negative 4x equals 12. But let's do it nicely. So we've got 0 minus 4x equals 12, substituting that y value into here. Negative 4x equals 12 gives me x equal to negative 3. So the x-intercept is going to be at negative 3, 0. All we have to do now is to plot those 2 points and join up the line. So we've got 0, 4. Where's it gone? Here we are. 0, 4 up here. Right. And then the other point that we had was negative 3, 0. So I just grab my ruler or my snapper card if I haven't got a ruler, and I join those 2 points up. And that's my line. So that's a really nice way to do it. But the other way we can do it is we can get it into mx plus c form. So let's do it that way now. Either method is fine. 3y minus 4x equals 12. I want to end up with y equals blah blah. So I'm going to start by adding 4x to both sides. I get 3y is equal to 4x plus 12. Next I have y equals 4/3 x plus 12 divided by 3. So what did I do to both sides? Well, I just divided everything by 3. Cleaning that up gives me y is equal to 4/3 x plus 4. So if I'm going to do it this way, what I'll do now is go back to that grid and use our usual method where we start with the y-intercept and then we use the gradient to find the next point. So here's this graph. Let's take that line off. Now it's a little bit tricky because of how I've got the GeoGebra grid. But I'm going to start at 4 and then I want to go, let's see what we had, out 3 and up 4. Oh, where's it gone? Disappeared. Here we go. So we're going to go out 3, and you can see that I can't go up 4 there. But I can do it going the other way around, right? So we're going to go back 3, and I'm going to go down 4. And you can see that I'll get back to that point that I had when I found it the other way. Right, so we start with my y-intercept, and then use the gradient to get the next point. Either of those methods works fine, and it's good to be confident with both of them. We're not expecting you all to be able to do this cover-up method at Year 9 because it's got quite a few steps that we have to link together, but hopefully some of you will enjoy this method as well. Thanks for watching. Leave me any comments if you've got questions. Education Perfect is good on all of the skills in here, and the relational worksheets that we've posted should also help you with this one.